Module 4, Database Structures. First, I'd like to show you the 4 system databases that are shipped with any copy of SQL Server. These are vital to the core operations of a SQL Server instance, especially the master one, because it contains metadata, which is system data for critical operations, such as logins, user database mappings, and many others. Backup, restore, and SQL Server agent-related tasks are stored in MSDB, while the model database serve as scheme for creating user databases because they pick up the same setting as is defined on the model. And finally, there is the TempDB one that is heavily used by applications and production servers as they deal with temporary objects. The TempDB, it is critical for the workload of a production applications using the SQL Server, and it is the best practice across the market to isolate its data and log files from other databases, so they do not compete for I/O resources and have the performance optimized. There are many articles and even books about how to configure properly TempDB for different workloads, and there are many options for tuning it, so consider this just a glimpse on TempDB content. And another important fact to mention is that TempDB, the size of it, is reset whenever the SQL Server restarts, so there is no backup or restore of this database. And on these black boxes you can check some examples on objects stored by TempDB. Next, I'm going to show you the file structures of a SQL Server database. Any database must have at least one data and transaction log file, and their extensions are the .mdf and ldf. And there are the secondary data files as well, and the log files, but these are optional and you will not see them on every database. It's really a matter of design according to each database particular need, according to each application need. And finally, there's the file group concept, which is a logical layer where you can assign specific files to put into. The default is primary. And what is the content on each of those files? The data files, as the name says, it's where the tables actually are in the format of data pages. And the function of the transaction log is to maintain the records of each operation that modified data, such as inserts, deletes, or update. Now to the Autogrowth properties for the log and data files. Both data and transaction log files, they must be able to expand themselves if required. This can be achieved with the Autogrowth properties that a DBA can configure to tell SQL Server how to deal with each file, whether it will grow in a percent or by megabytes or gigabytes, whatever, and if there is going to be a limit or not for this growth. Now, for this question, which Autogrowth option is better? There is not really a single answer for this because it depends on your workload. It depends on your environment. In my particular experience for production servers, I see more often the Autogrowth set to a specific amount of megabytes instead of percent. This is because if you set to a certain amount, say 10%, and your database is very large, something like 1 or 10 terabytes, every time there's a need for expansion, it will be 10 gigabytes, leading to the file physically expansion increase, so it will consume additional storage without having the need to do so. Now, for the next 4 slides, we will look into some aspects for the transaction log, as it is a key component of the SQL Server databases. Remember the first module when we looked into the asset properties. The D stands for durability, and this is what the transaction log does. It allows a transaction to roll back and allows SQL Server to revert changes that were done to a database by keeping track of everything that was changed with the backup of these logs. The transaction log consists of virtual log files, and these are constantly being reused. We will see a little bit more about them on the next screen. It is also good to remind that the transaction log is sequential. The error 9002 is a classic when dealing with transaction logs. Eventually, you get at least to see one if working as a production DBA. We will see it happening on the practice demo. Here at the second bullet, I have highlighted the top reasons that a transaction log fills up. active transaction, or missing log backup in case the database is in a full recovery model. When it is such a simple recovery model, the truncate of the virtual log files, which release internal space, happens with a checkpoint when the database log space reaches 70% full. I'm going to present some more details about the recovery models on the next slides. And here in the final bullet, the statement is that there are no performance gain when creating multiple log files because they are written sequentially. And here is to emphasize the fact that only one virtual log file is active at a time, no matter how many of them exists inside the transaction log file. The other ones are marked as inactive, while only one is in use, and this table shows the amount of ELFs exists according to each file size. There are recent changes to these numbers on SQL Server 2014, but they will not be covered in this course. However, if you are interested in checking about this, I recommend to take a look at Paul Render's blog on sqlseals.com. Now, in the last slide about the transaction log, I wanted to show you some internal components of a log file structure. These concepts are not commonly used in day-to-day troubleshooting, but it's something worth to be aware of. So each virtual log file has log blocks inside it, and each log block has 60 KB max. And inside every log block we have the log records. And on every log record we have the actual data changes that happens inside during the transactions. And notice that a single log record can hold changes from different transactions at the same time, as each one of them is unique. And this is how SQL Server keep track of everything using the LSN, which is the log sequence number, to identify every operation. And in the case some action requires to be reverted or reapplied, that is, rolled back or rolled forward, SQL Server is able to do so. Now, moving forward on this module, I wanted to present you the shrink file considerations. I wanted to emphasize this command as it can be tricky sometimes if you are unaware of the consequences, especially when using it on production environments. So I'm going to exemplify through some images next. Let's imagine a database with a single data and log files. And on the data file, we have physically 1 GB of size and 99% of internal free space. Then we have an insert operation that fills up 80% of this internal storage, leaving 20% of free space. Notice the overall physical size remains the same because it has not yet reached the limit, so we're not considering autogrowth on this particular example. After this, let's consider there was a delete statement that wiped out the recently data and left the data file with 80% of internal free storage. I'm not considering here changes to the transaction log file because delete operations are costly, so I'm not considering these now, only the data file. And at this time, the shrink command takes place in an attempt to reduce the data file physical size to save disk space. And let's assume the command worked, but it has a cost, index fragmentation, that we're going to see in the next demo. So here's the overall summary. The shrink file operation in data files can lead to several index fragmentation and can degrade performance by slowing down the query's response time. The larger data file is, the longest is the time for a shrink file command to work, and it can even enter in conflict with other operations, such as backup, if they're running at the same time. I have seen situations where a shrink file ran for up to 10 hours in production servers, and this must be used only as a last resource. Instead of having to reduce data file physical size, the best method to avoid such scenario is to have periodically data purge or archive to avoid uncontrolled growth. Should you run in a situation where the shrink data file is required, make sure to communicate with the client and consider a time frame for rebuilding or reorganizing the indexes right after. The shrink on log file does not have the same impact as the transaction log, has only tracking data. However, if you use it with frequency, it means the capacity surrounding the transaction log should be adjusted. Either the disk where it's located should be expanded, or the application using the SQL instance should control the excessive log growth by reducing the volume of costly operations such as deletes and considering bulk logged recovery model, periodically data purge, or other actions. Now let's take a look at the database recovery model options. When we create a new database or adjust the properties of an existing one, the recovery model plays an essential role because it determines how the database will behave in regard of the backup capabilities. So here we have the full recovery model. This is the most common to see in production servers. It allows the transaction log to be backed up, so in case there's a need to revert database back to a previous state in time, this can be done by using the transaction log backups. And we will learn more about point-in-time recovery on the next module. Next, we have the bulk logged recovery model. This one is used on specific situations where huge data loads are being generated and it generates less activity in the transaction log as possible. So it's more like a temporary recovery model to be used in certain cases. And we have the simple recovery model. It has some limitations as it does not allow log backups, and it's commonly used in databases that are not updated with high frequency, such as reporting databases for read-only purposes or databases where a full backup is more than enough to comply with business needs. And there are many other adjustments that can be done in a single SQL Server database because many properties are available. And here I'm going to highlight a few to be considered. Here we have the auto create and auto update statistics. These must always be turned on. If they're turned off, it means that the DBA will have to manually keep the statistics up to date, and this is not a best practice across the industry. We have also the auto shrink and auto close, and they are dangerous also be turned on because they affect your database availability and you have little control over the data file structure. So make sure that if you see one of these options turned on, you have a very good reason to keep them like this. Now let's begin the demo for this module, where I'll present you two exercises. The first will be creating a new database, inspecting the properties, changing the Autogrowth settings, and producing some common errors we see on production servers. And on the second exercise, I'll show you the impact of the shrink file on a data file in SQL Server to see how it causes index fragmentation in a database. So let's get things started. So here is the first exercise. The first step is to create a new database. And there's a comment here. I mentioned that for this exercise I'm doing, notice that I am putting the physical data and log files on the root for the C drive. So the service account running SQL Server must have administrator rights on the C drive. So these are the settings that I'm going to use on this command. New York data will be the logical file name. Here's the physical path. Initial size 100 megabytes. No autogrowth. This is intentional for us to produce the errors. And the transaction log will be on this path also. And here's the logical file name. Same thing, 100 megabytes without any growth. Let me hit execute. There it is. And I'm going to inspect the properties using the graphical interface. Right away you can see there's no database or log backups because we have just created it, so this is normal. If we go to files, there is the exact information we put there in the command. The file name, the physical path, C drive, no autogrowth or max size specified. The initial size is 100 megabytes for each file, so the database overall has 200 megabytes. The file group for the primary data file, and the logical name. Another thing I wanted to show you here is the option tab. We commented earlier on the previous slide about the auto close, create statistics, auto shrink, and auto update options. And as you can see, auto close it's turned off, create statistics turn it on, auto shrink, turn it off, and auto update, turn it on. As you can see, there are many other options here, and normally these settings, they're only changed when the application or when your client requests you, the DBA, to do so, because these are very specific to the database behavior, and generally when you create a new database, they come just like this by default. Okay, so let me hit cancel here. Oh, before that, let me show you the recovery model. This is where we check. As you can see, the default is full because in the model database that serves as a scheme for new ones, it has the full recovery model. So it picks up from the model. You can change here from simple and bulk logged. But for now, I'm going to leave it with full. I'm going to hit cancel because I was just inspecting the properties. Nothing was changed at all. The second step is to create some tables. I'm using here this data type chart 80,000 bytes because it will cause my database to fill up quickly when I insert data next. And this code, we are going to use it to monitor the data and log free space. As you can see, overall size of the database 200 megabytes, unallocated free space almost 98 megabytes. This is the free space inside the data file, and the usage of the data file in megabytes only 2.5, and the transaction log almost near to 0. Number 4, I'm going to fill up data until I produce an error on this database. So I'm creating here an infinite loop while 1 equals to 1. I'm going to insert data until the capacity can handle. It will take a few minutes for this to complete, so I'm going to pause the video and return when the command completes so we can see the error and start the troubleshooting based on it. So here's the error that was produced by my script. Could not allocate space for object. This is a table and primary key in database New York because the primary file group is full. So basically, SQL Server is telling us that the data file inside this primary file group is full. And it already mentions here some workarounds to correct this problem. So create this space by removing unneeded files. You can drop objects in the file group, add additional files, or change the Autogrowth settings. And before we explore these workaround options, I'm going to show you the monitor space script again. Before, remember, the unallocated space was almost 100 megabyte, and now almost nothing because the data file space used in megabytes equals to 100. The log utilization also increased. So let me go back here to number 5, workarounds, so we can explore the options that SQL Server gave us. The first one, here I'm adding a secondary data file, name it New York Data 2. Here's the logical name, again the physical path. I'm giving 50 megabytes for this one, restricting the autogrowth to 100 megabytes and allowing 10 megabytes of expansion to the file group primary, which is the only one we have. There it is. So if I run the monitor space again, look at the unallocated space and database size. Of course, it has expanded, and now we have 50 megabytes of free space, and the database size just increased. But the data file, first data file used, that I'm checking it here, New York data, still has 100 megabytes full. So another workaround to reduce it is to delete data from the tables, and this will provoke the 9002 error that I commented earlier in the transaction log section. So let's run this, and right away you can see an error shown to the screen. Transaction log for database New York is full because of an active transaction, which was this. So if I try to check this now, I'll not be able to find any transaction because it rolled back as it completed with errors. So the delete statement has a very high cost to the transaction log because it has to record everything on it in case there's a rollback. So these type of operations are very costly for SQL Server and cause the log to grow very fast. And since our transaction log has no autogrowth, as we've seen here, no autogrowth for the transaction log, it causes this famous error. And this command I wanted to show you because it's normally used to verify whatever it's holding the transaction log from truncating. When the transaction log truncates its internal virtual log files, the log space is reused. And sometimes if there's an active transaction here, or log backup means you need to take any actions. But since our transaction that caused the error already rolled back, there is nothing here. You can also inspect the SQL Perf log space for the New York database. You can see the log size almost reached the limit, 99 megabytes, but from this current size, only 5 megabytes are in use because it truncated itself after the rollback. Third workaround, I'm going to purge the data using the truncate. There it is, completed successfully. Let's take a look at the monitor space script again. Once more, there it is. Now unallocated space 147 megabytes, and you can see the data file space used for the primary data file reached only 2.5 megabytes, just like it was at the beginning. So what is the difference between the truncate table and the delete statement? The truncate does the same as the delete, but the difference it has a lower cost to the transaction log than the delete statement. It still has information logged there, but in a very different manner, so it wipes data in a more fast way. But you should be careful when using it in production. This is only a lab. Now let's go to the fourth workaround. Let's enable the autogrowth settings, outer database, New York. I'm modifying the file using file growth to allow the transaction log to expand itself every 1 megabytes, and let's see what happens. I'm going to reset the exercise now and pause the video so we can actually see what happens to the transaction log after the delete statement works without any errors. Alright, so I reset the exercise, and now instead of doing the first and second workaround and third, I'm going to directly go here and change the autogrowth for the transaction log file to 1 megabyte, and I'm going to try to delete the information from the tables and see what happens. I'm going to pause the video now and return once the script is completed. So there it is, the rows affected. Let's take a look now at the monitor space script once again. You can see log file space used in megabytes. My transaction log has now 179 megabytes, and look at the database size, already expanded, because the delete operation, as I mentioned before, has a high cost to the transaction log. It's a best practice recommended by many articles. You'll find this on SQL Server books, that when you are purging data from the SQL Server, when you want to delete data from very large databases, you do this from time to time and split the process. Otherwise, you're most likely going to run in a transaction log error, just like we did here. Now moving on to the next exercise, this is the shrink file demo. I'm going to start by creating a test database, name it shrink test, just like the previous exercise, without any autogrowth. Transaction log here on C drive. There it is. Another script to monitor the database space, just like we did before. Okay, so we have 100 megabytes database, almost everything unallocated, and only the data file space used we are concerned for this exercise. Now I'm going to create a table named heavy load, and I'm going to insert some data until the limit allows. So let's wait a little bit for this script to run. I'm going to pause the video now and come back a few seconds later after the command is completed. So here is the result. The command completed without any errors. If we look at the monitor DB space again, now we have 1.38 megabytes only of free space, and the shrink test data file reached almost the full capacity. The next step is to check for the index name. Since I have created the table with the primary key, SQL Server automatically generated a cluster index. And I'm going to check for this cluster index fragmentation level by running this. You can see it's below 1%, so it's not a concern right now. And I'm going to intentionally purge some data to see what happens. It should only take a couple of seconds. There it is, the rows affected. If I go back here, oops, it's at this. Hit execute, only 0.10% of increase, so still not a concern. But now, let me shrink the data file to see what actually happens. And before I go to do this, I'm going to inspect the properties again for the data file. You can see 100 megabytes, shrink data. Let's run this. Okay, the command completed. Let's inspect what happened here. There was a 40 megabytes reduction for the physical size of this shrinkdata.mdf data file. If we inspect the properties again for space, you can see the database size now 120 megabytes, but the shrink test data file space usage only 58. And the reason for this growth was because the transaction log has expanded. If we hit properties and files, you can see 62 megabytes for the transaction log, but it was before 1 megabyte. So the log has expanded as well. That's why my database overall size increased. Now let's take a look at the fragmentation level after the shrink for the cluster index. See, there's a huge increase from less than 1% to 45%. That means a lot. And in production servers, when we deal with very large databases and a very large amount of cluster indexes or non-cluster indexes, this level of fragmentation can cause performance degradation by slowing down query performance. So let me pick the index name again. This. I'm going to run a reorg index, changing the index name. So outer index, the index name on table heavy load. I'm going to rebuild it, see what happens. It's going to give me a space error because the primary is full, primary file group is full. Because the rebuild, it's a more costly operation for the transaction log and for the data file other than the reorg. So I'm going to use reorganize instead to reduce the fragmentation level. Let's check it here now. Remember, it was 45%. Now, after the reorg, let's check what happened. Back below 1%. So we had to do this to recover the status after the shrink. Or we could have done this. Autogrowth settings, change the autogrowth settings for the shrink data file, and then run a rebuild. So the most important message from this exercise is, whatever you do this in production, imagine a very large database. The shrink file command could run for a couple of hours. I've seen situations where it ran for like 8 to 10 hours. And after that, you need to have a window available on your server, an outage window maybe, to run a reorg or rebuild indexes on the whole database that you executed the shrink. Otherwise, you have a huge fragmentation level and the users can feel this impact since their queries are going to be slowed down.